Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic Time Division Multiplexing, TDM. So first we can see what is this multiplexing. Any medium can carry only single signal at any second in time. So to transmit the multiple signal through any medium, the medium has to be separated by providing every signal a segment of whole bandwidth. This can be possible by making use of the multiplexing technique. Multiplexing is a technique which is used to combine various signals into a single signal using a shared medium. There are different types of multiplexing techniques like TDM, FDM, CDMA, WDM, which are utilized in the data transmission systems. We are going to see about what is this TDM, time division multiplexing. Time division multiplexing or TDM is a multiplexing technique that is used to transmit two or above streaming digital signals above a common channel. In this type of multiplexing technique, incoming signals are separated into a equivalent fixed length time slots. Once a multiplication is done, these signals are sent over a shared medium, and after demultiplexing, they are reassembled into a original format. And this is the block diagram for PAM TDM system. So it consists of a low pass filter, pulse amplitude modulation, communication channel, pulse amplitude modulation. It will be having a commutator at the transmitter side and receiver side, and will be having this low pass filter, a transmitter and the reception side. And we have this pulse amplitude modulator in the transmission, and the receiver will be having this pulse amplitude demodulator. So in TDM block diagram, there is a number of low pass filters present at the beginning of a system based on the number of the inputs. Basically, the low pass filters are the anti-aliasing filter that removes the aliasing of data input signal. After that, low pass output is given to the commutator. According to the commutator's rotation, data inputs samples are gathered through it. Suppose we have n inputs, then according to revolution one after the other, the data inputs will get multiplexed and transmitted over the common channel. At the receiver end of the system, decommutator is used, which is synchronized at the transmitter end commutator. So this decommutator at the receiving end divides a time division multiplexed signal. So next we are going to see how this time division multiplexing works. Time division multiplexing method works by putting several data streams within a single signal by dividing a signal into various segments where each segment has a very short duration. Every individual data stream at the receiving end is reassembled depending on the timing. In TDM diagram we have seen here, in the previous diagram we have seen three sources A, B and C. We want to send the data through a common medium. The signal from these three sources can be separated into various frames where every frame has its own fixed time slot. In TDM system, 3 units from every source are taken into consideration that forms the actual signal jointly. A frame is collected with a single unit of each source that is transmitted at a time. When these units are different completely from each other, then preventable signal mixing chances can be removed. Once a frame gets transmitted above the specific time slot, then the second frame utilizes a similar channel to get transmitted, and further this process is repeated until the entire transmission is being completed. And next is the advantages of this TDM. The circuit design of this TDM is very simple. TDM uses a total bandwidth of channel for signal transmission. In TDM, the intermediation distortion issue is not there. And TDM systems are very flexible compared to FDM. For every channel, the complete available bandwidth is used, and sometimes a pulse overlapping can cause a crosstalk. However, it can be decreased using this guard times. In this multiplexing, unwanted signal transmission between the communication channel takes place very rarely. And drawback of this TDM is that both the transmitting and receiving section should be synchronized properly to have the right signal transmission and reception. TDM is very complex to implement. As compared to FDM, this multiplexing has a lower latency. TDM systems require addressing the data and buffer. The channels of this multiplexing may get exhausted because of slow narrow band phasing. In TDM, synchronization is very difficult. In TDM, buffer and address informations are very essential. And next is the applications of TDM. It is applicable in telephone systems. It is used in wireline telephone lines. This multiplexing is it is used in telegraph in early days. TDM is used in cellular radios, satellite access system, and digital audio mixing systems. TDM is most common technique used in fiber optic communication. It is used in cellular radio, digital communication, and satellite communication. So that's all about the TDM. What is TDM and what is a block diagram, and also how the TDM works. And we have seen those advantages, drawbacks, and applications of TDM. Thank you.